In the previous video, we say that we want to do an example for Eulers, right? So therefore, let's do it. Alright, so for the compensation, some ds, I don't know what is it, but ds is simply us over es. Alright, please take note of this. Okay, so in order to solve this function, alright, use the forward rectangular method and also repeat the calculation using the backward rectangular method. So we're going to do both methods and compare the difference between their coefficients, okay, with a certain sample rate of 80 Hz. Alright, it's kind of tedious, so let's do it. In order to solve it, let's continue back in our general equation that we have derived in the previous video. Alright, we say that this one is the u dot t, correct? This one is the e dot t, and then we sub in the Euler's formula for the forward. This case is the forward still. Alright, this is the forward method, and let's see whether how can we exploit this general equation. Alright, by simply subbing in all this. Alright, if I were to do that, what we have is this one. Alright, I just simply sub in u and this one over here. Okay, same applies for this one. What I have is this equation, and what can you see? We can see that we can actually so-called, this shouldn't be the case. Please do not take this for real. No. Okay, we cannot do that. This one is inside. This is not like multiplication. This is stating that u in terms when k plus 1. This is some variable k plus 1. Alright, please don't do that. Please don't do that. Sorry, my fault. Okay, forget it. Alright, so what I'm gonna do now is simply to bring this one, alright, to the other side. Alright, so when I bring this to the other side, what I have is this one. Okay, what I have is this one. Now I just want to repeat again that please do not multiply in. Don't do that. Don't. Okay, now we just move to the other side. Now we bring the t up to this top. Alright, so if I were to move it up, then what I will have is simply so be very careful of this thing. Alright, so this is t. Then I'll just erase this off. Also, to define that this is k naught. This k is different from the k over here, we have said earlier. Alright, I asked you to solve this one. Why are you doing all this thing? Why are you doing the general equation? So later on, as we say, the general equation is when you sub in things, then you can straight away do already. Alright, so I don't know whether can this module be able to open book. If open book, then you can just sub in the values. But I just want to prove to you that when you sub in the values, it's straightforward than when you do it yourself. But still, we will just do it in terms of subbing the value, and this is easy. Later on, we will do an example just on solving it in the longer way. Alright, in terms of the one that I've said. So to continue, I want to express things in terms of uk plus 1. Alright, so I'll just bring this thing over here. Okay, what I would have, instead of minus, I'll have plus. Right, I have plus over here. Okay, in fact my fault is that, if you remember, this is actually ek. Alright, t changed to k. I actually forgot to do that. Okay, and what I need to do now is just to simply multiplying all this stuff and see what we can salvage from that. So I can simply group the terms, right? uk and uk is simply over here. They have constants of uk. They are the same dude. Alright, what are the other stuff that are the same? This one, minus ek and t and aek. Right, they are the same. Alright, and just only this one that is something extra. For the green color one, I'll just highlight them in green. So I'll just sub it in. So I'll have uk minus buk. Alright, this is simply the triangular one for this two. I'm just grouping them together. Alright, not forgetting that this t will be multiplied in. Alright, so it's tbuk. I'll expand first later on, then you'll know what I mean. I think this is a bit confusing for you. So UK plus, I'm just multiplying t into this whole stuff. Alright, what I have is I multiply t into all these terms. Alright, is what I mean. Okay, and therefore if I were to do that, I would have I just want to show you at least you know how it's being derived. Alright, now just simply multiplying the t for each term. Alright, this term, and this term. Alright, like that first. Alright, so now I expanded t in that manner. If you remember back, that's not an equation. Alright, I'll just show you. What is this? So actually I just multiplying the t, alright, multiplying the t into each of this term first. Alright, because this whole thing is bracketed by k naught. Okay, in other words, if I were to bring in the k naught now, I think it would be better lah. Okay, this k naught is multiplied into each of this term. You get what I mean? So it's within, it's just a rearranging. So I think I'll just multiplying the k naught into here and here first. At least it's easier for you to see. So when I'm multiplying k naught over here, what I will have is k naught e k plus 1 minus k naught ek. Alright, divided by t plus, now I'm multiplying k naught into this term. Alright, so k naught a k. Alright, and then bracket t minus buk bracket plus uk. Okay, next I'm simply multiplying t into all these terms. Okay, if I were to do that, I would have this thing. In fact, if I multiply it into this whole thing, this t will cancel out with this t. Alright, later on you'll get what I mean. So I'll just simply copy this one because it's straightforward. Alright, maybe the whole thing. So if I were to multiply in each of the t over to this side, what I would have is t times t times t. Alright, plus this one. Alright, uk. Okay, so I'm just simply, in other words, what I'm doing now is to rearrange all this into one equation, one simplified equation. I'm just simplifying now. Okay, it's like a long chunk, but you just take note of it. Alright, so this t will cancel, this t will cancel. What I would have will become uk plus this. Alright, so this whole thing is being simplified into here. Alright, it's just only cancelling the t lah. Alright, that's all. Okay, what I would have now, simple, I can group already, right? So when I group, I can say that uk and uk is grouped together as one set, maybe minus with the minus also. Alright, and ek I'll group them together as the constant. Right, ek and ek, I can group them as a group. So what I will have, this means that I'm actually factorizing things. Alright, so I can group, in terms of green color now, alright, I can just put as 1 minus tb uk. So I'm just simply rewriting this term and this term as this. That's all. Okay, plus, alright, now I'm gonna factorize out the ek out from this two stuff. What I have is tk. In fact, k naught are the same. Alright, so I can just factorize out the k naught also. So I just factorize the k naught over here, and we will have ta minus 1 over ek. That's all, I think. Yeah. So I'm just simply factorizing out k naught and ek, since they're actually all related. Alright, later on you will know what I mean. We are going there already, we are near there. And then left over is this one. I'll just simply write it over here. Alright, and this thing is the general equation. Alright, of uk plus 1. Alright, we actually simplify this whole chunk into what you have seen over here. Alright, so I'll just simply allow the uk plus 1 to be placed over here. Alright, is equals to, okay, so over here, and you can actually access it in your thing. It's actually in this page, the same thing. Okay, now you can simply rewrite this thing as c1, this constant as c2, and this constant as c3. Okay, so I can rewrite the whole chunk of this stuff is this c1 uk 2 ek plus ck plus 1. Alright, where c1, c2 and c3, alright, I'll just draw a table. Forward, alright, is 1 minus tb. Alright, c1 is this one, c2 is k0 ta minus 1, and c3, the last one, is actually k0. Yeah, okay, k0 is simply just a constant. ek plus 1 is the name of the derivative, like ek, this is ek plus 1. Alright, so as you can see, this is actually, I should put ek also. Anyway, so here, like this. Okay, so this is for the forward loop, the general form. Alright, and if you take a look inside your exercise, this is the practice question. This one is the one that we have derived. Okay, if I were to paste this, it's exactly the same. Alright, c1, this one, c2 is this one, c3 is this one. It's the same thing. Alright, so this is for the forward loop, and for the backward loop is simply what we have done for the forward loop. We'll just do in terms of the backward. Alright, I'm not going to derive this because it's going to be damn long, but when you derive this, you'll get eventually these constants over here. Now, since we have all these constants, then we can do things very simple now. I didn't explicitly define forward and backward. This is the forward. We derived that in the previous video, and now we derive all the rest of the constants c1, c2 and c3 for the forward loop over here. Alright, and as for the backward, I say that I will not do it, alright, because it's gonna be the same stuff but slightly different things because the equation is different. But we're gonna go through all these processes and derive the same c1 and c2 and c3. Alright, so that c1, c2 and c3 will be different from the forward, but it's in terms of this matter right now. Alright, so this is a form of at least explicitly define that how the backward comes from. Alright, and if we were to go back to the question over here, now we can simply know these things already. Let me just copy this stuff. Alright, and so with these values, we know that this is k0. Alright, this is a, this is b. In other words, k0 s plus a divided by s plus b. This is what we have came out in the last video. Alright, some equation. And therefore I can just simply sub it all inside here. Alright, but given that we know that t is equals to 1 over f, and our frequency is given as 80 Hertz. Alright, over here, 80 Hertz, sample rate 80 Hertz. And it's a sample rate 80 Hertz. But when I sub in all this value, is the same as what I've shown you just now. Let's sub in into here. What I will have is c1 for forward is this value, c2 is this, c1 is this one, c2 is this one, c3 is this one, for both forward and backward. Alright, you can simply sub back into this equation. So for example, it will be like 0.8125 minus 24.6875 and 25 ek, and so on and so forth. And then this k, alright, if you still remember, a certain first first feedback we will generate a first k1 value. Alright, second feedback will generate a second k2 value. So k2 point is over here, k1 point is over here. When you sub it into this equation, for example, what I will have is, in other words, I will have, okay, anyway, I'll just do it here first. Alright, so when I sub in k2 and k1, okay, I'll have a point over here. So for example, if I sub in k1 over here, what I would have is simply a uk plus 1. Alright, which is somewhere over here. Okay, what I mean, let me repeat myself again. Alright, if I have a system that feedback one time over k, the first time, this is k1. Alright, and it will be feedback into all this system, k1, because this is just simple k. Okay, and it has, because uk is a certain function, maybe in terms of k squared plus 1, this is maybe 2k plus 1. So if k is maybe 3, then this will become 10. Alright, 3 squared is plus 1 is 10, and then 3 times 2 is 6, 7. So this one will be a certain value. So in this case, this 10 will multiply by this c1, this 7 will multiply by this c2. Okay, and then when the system generate another value of k2, alright, meaning the next value of k, it will sub it inside this equation over here. Alright, and the sum values will be like maybe 50. And then this value will add up together, will give you this value over here. Alright, for k plus 1. Alright, so in other words, this k1, certain information, we know that this part over here is u, right, the output, and then over here this part is e, alright. So therefore, the first k1 value that comes into here will be plotted over here, and maybe for the input it may be somewhere over here. Alright, for example. Alright, and then the next input that comes in for k2, alright, you will plot. Alright, you will plot over here. And once k2 comes in, the next value, there will be a value for this thing already. It will be over here. This point will come here. Okay, and what you sub in over here as k1, and this one as k1, and this is k2, when you add them up together, you'll give you a value for k2 in u, which is at the output. I think you get what I mean? Good job. I also don't know what I mean. Let me explain again. Okay, this time definitely can. Trust me. Okay, we have a k1 over here. I input into this system. Alright, this k1 is for the e. Alright, this input. So I plot a point over here. Okay, k1 with its relative functions lah. So if I input k1, some values will occur, and I'll just place over here. This value is for the function of k. So for example, k squared plus 1. If I know k is 2, then it's this function is equals to 5. I'll just plot over here. Okay, so far so good. Nice. Then this k1 comes to here. Alright, it's gonna output, straight away output for uk. Alright, and therefore it is, so we plot it over here at this point. Alright, this is for the output. So far so good. In fact, should add in a feedback system over here. So this k1 goes in this direction. There will be another k1 that is go into this direction, into this feedback system. Come out, it will become k plus 1. Alright, interacting with this one over here. And if we're going into this term right here right now, this will generate k plus 1. Alright, we shall sub it. In fact, it's not over here, it should be over here. Alright, this new input over here, alright, this new input over here will be k2. Okay, and this k2 will be sub it in over here. Okay, therefore, to look at it, this is the input, the first round input. This is the feedback. So input plus the feedback will give you a certain output from the system. So this will generate a new UK plus 1. You get what I mean? And the system goes on in the cycle again. Alright? And therefore, when you plot this point over here, and you were to compare to this point, if I were to superimpose, meaning I take this point over here, right, for you, for input, apply it over here, the difference between them will be the curve, will be our differentiation. And if you were to join on up together, you'll have a line, you'll have a curvature. Alright, this thing is simply a point. Alright, this is just that's the thing. No, this thing is simply a point. You just plot the points only. Alright, when the interaction between these two so-called these two graph will give you certain curvature, which is what we have said in the previous video on graphical view of it. Alright, so therefore at least this is something I thought fairly useful. So you may wonder, I thought so much, then how can I present my answer? You can just present your answer as this one will do. Alright, with C1, C2, C3 with these numbers, applying a certain frequency, the 80 Hz, right? So that's it for that system. Unless they give you certain K value and the equation for UK and such, then things will go very complicated, as I've said in this scenario right here. At least you get to know how the signals is moving. So yeah, and then in the next video, if you want to get a feel of how it's calculated numerically, in terms of numbers, not in terms of general equation, alright, then in the next video it's that. Okay, bye bye.